Okay, so here in chapter 22, we're going to talk about transformation geometry. And so we're going to focus on rigid motions. We'll take a closer look at some of these and really clarify some vocabulary. We've already looked at some of these. So in chapter 18, we looked at transformations, reflections, and rotations. In chapter 20, we talked about dilation, so increasing the size, decreasing. In this chapter, we're going to go ahead and talk about some of these movements that do not change the size or shape, and we call those rigid motions. So let's start off with some vocabulary here. And so a rigid motion or isometry is a movement that does not change length and actual size. So that's what we're going to focus on in this chapter here. And so trying to just keep it the same. So let's look at this example here. We have an image, what looks like a letter F on some isometric paper here. And so let's talk about some of these rigid motions here. So, for example, if we start with our original shape, motion 1. Okay, so motion 1 here would be a translation. So again, just shifting over the object, kind of sliding it around without changing the shape or the size of it. If, again, we start at our original shape and we see what happens with motion 2, this would be a rotation among a point there at the bottom of that F, and we would rotate it 90 degrees clockwise, 90 degrees clockwise. We've also looked at reflections here. So if we were to do an axis there, if we reflect this, make that mirror image, so reflected along a line or an axis, sometimes we say. And then motion 4 is really going to just be a combination of them if we actually do a translation, so moving it over, and then a reflection. And so we call that a glide reflection. So really a composition of our 3 traditional: translation, rotation, and reflection. So really a composition of those where you're using 2 of them. But it's used often, so we call it its own name, a glide reflection. So let's look at activity 2 here. And so let's see which of these shapes here, 2-dimensional shapes here, are the same here. So could we perform some of these rigid motions on them? And so to explore this, let's call our first image A here our original, and we'll compare the other images to that. So let's look at image B here. And that's going to be a rotation of the original. Right at the center, if we were to put a point in the center of the object, flip it around there, 180 degrees, that'll give us a rotation. Everything's still in the same orientation. C would also be the same here. This is a reflection. So if we were to put that line of reflection right on the actual object there, you could just reflect it among itself. Now, D would not be one because we'll see the orientation of that hand, of that left hand is actually upwards, and the right one as well, but the hands are swapped, but nothing else. Similarly, we see E, again with those hand gestures going upwards rather than down. And F would also be the same. It's actually exactly the same, right? So the identity, exactly the same thing. Nothing has changed here. So perhaps rotating it 360 degrees from the center. G, again, the hand orientation is off, so that would not be the same to our original. And then H would be a rotation. And in fact, this is really the same as B, right? Those guys are the exact same image there. And if we look at these closely, the ones that we X'd out, those are actually going to be the same to themselves because the orientation is correct there. So those are just some rotations. So when we talk about these rigid motions, the new image we create is called an image. And we talked about moving these like the points on the actual image itself. But really, we're talking about the whole entire plane. So for example, if we look at this original shape and we want to do a rotation, the point of rotation could be somewhere off of the shape itself. It could be anywhere on the plane. So we pick a point there and then we rotate it along there. So we see the distance is going to be the same to those vertices. And that'll be roughly about a 90-degree rotation or so. We could also talk about a translation. Again, moving all the points on the image, but really we're moving all the points on the entire plane, so everything shifts over. And a reflection here. So again, the distance here from a line of reflection, and this is similar to what we looked at before, but that distance would be the same. So we could talk about that reflection anywhere on the plane. Doesn't always have to be on the image itself. And then, of course, a glide reflection, which would just be a combination of them. So perhaps doing a reflection first and then getting us to this point here. And then doing a translation here. So moving us down to there. So again, a composition of those, just doing a reflection and a translation. So a bit more of definition here, what we think of as congruent. So we say two figures are congruent if one of the image of the other after some rigid motion. So two figures are congruent if one is the image of the other after some rigid motion. So after we perform one of these rigid motions, if they end up being the same. So again, not involving dilations. That's going to make it larger, right? Or smaller. We want to keep it the same size and the same shape without moving it around. And then takeaway for this section is that in the plane there are 4 types of rigid motions or isometries: reflection, rotation, translation. And again, I would argue glide reflection is really just a composition of a reflection and a translation, which we'll look at in the end of this chapter.